Welcome to our Blackboard Education channel. In this session, we are going to discuss about class 10th, Chapter 3, Acid, Bases and Salt, part 9. Dilution of acid or base, strength of acid or base. First, let us see how to dilute acid or base. Mixing an acid or base with water result in decrease in the concentration of ions H3O plus or OH minus per unit volume. Such a process is called dilution, and the acid or the base is said to be diluted. The process of dissolving an acid is an exothermic reaction. Care must be taken while mixing concentrated nitric acid or sulfuric acid. Here you can see warning symbol. Here warning sign displayed on containers containing concentrated acid or base showing that it is harm. Now let us see how to prepare dilute sulfuric acid. The aim of the activity is to preparation of dilute sulfuric acid. For that, the material required: test tube, water and sulfuric acid. Procedure: take 10 ml of water in a test tube or a beaker. Add a few drops of concentrated sulfuric acid to it and swirl the test tube slowly. If we touch the test tube, we feel hot because the process of dissolving an acid is an exothermic reaction. Care must be taken while mixing concentrated nitric acid or sulfuric acid. The acid must always be added slowly to water with constant stirring. If water is added to concentrated acid, the heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to excessive local heating. Now in this session, let us perform an activity to see that what would happen when acid is added to the water and how we need to dilute the concentrated acids. For that, I am taking here a beaker, sulfuric acid concentrated and water. First of all, let us take some water in a beaker. I am taking water in the beaker and now measure the temperature of this water. Just here I am measuring the temperature of this water. So this is the showing that it is just observe here, it is showing that it is 30. It is 30 degrees Celsius. Now let us add sulfuric acid to it, drop by drop. So using dropper, I am taking sulfuric acid. Now here let us add sulfuric acid drop by drop. So when you touch the beaker, we feel hot here. Now let us measure again now sulfuric acid solution temperature. So here in previously the water showing that it is only water shows that it is 30 degrees Celsius temperature. Now it is showing 32 degrees Celsius temperature. Means here while adding sulfuric acid to the water, the heat is produced. This is exothermic reaction. That's why to dilute concentrated acids or bases, we need to add acid drop by drop to the water, but we should not add direct water to the acid. Why? Because it is exothermic reaction. If we added water direct to the acid, the huge amount of heat will be produced in the least time, so that it will fall our body, so that it will make harm to us. That's why that the dilution of acid or bases are exothermic reactions. So to dilute that acids or bases, we need to add acid or base to the water to get dilute solutions. Now, let us discuss about strength of acid or base. The activity here we are going to do is to find the strength of acid or base. For that, the material required: beaker, graphite rods, bulb, AC plug, dilute acetic acid, dilute sulfuric acid, dilute ammonium hydroxide, and dilute sodium hydroxide. How to do an activity? Connect two different colored electrical wires to graphite rod separately in a 100 ml of beaker. Connect free ends to the wire to 230 volt AC plug and complete the circuit by connecting a bulb to one of the wire. Now pour dilute HCl in the beaker and switch on the current. Repeat activity with the dilute acetic acid, dilute ammonium hydroxide, dilute sodium hydroxide solutions separately. Here we will observe that the bulb glow brightly in HCl or H2SO4 solution, while the intensity of the bulb is low in acetic acid solution. This indicates that there are more ions in HCl or H2SO4 solution and fewer ions are present in acetic acid solution. More ions in HCl solution means more H3O plus ions. Therefore, it's a strong acid, whereas acetic acid has fewer H3O plus ions and hence it is weak acid. Secondly, bulb glow brightly in dilute sodium hydroxide solution, while the intensity of bulb is low in dilute ammonium hydroxide or ammonium chloride solution. This indicates that there are more OH minus ions in sodium hydroxide solution and fewer OH minus ions present in ammonium hydroxide solution. Therefore, sodium hydroxide is a strong base, ammonium hydroxide is a weak base. Now let us define what is strong acid. An acid which produces more H3O plus ions in water is said to be a strong acid. Example: HCl, H2SO4, HNO3, etc. Weak acid. An acid which produces fewer H3O plus ions in water is said to be a weak acid. Examples: acetic acid CH3COOH, carbonic acid H2CO3, phosphoric acid H3PO4. Strong base. A base which produces more OH minus ions in aqueous solution is called a strong base. Means a base which is completely ionized in water is said to be strong base. Example: sodium hydroxide, calcium hydroxide, zinc hydroxide, etc. Weak base. A base which is partially ionized in water and produces fewer OH minus ions in aqueous solution is called a weak base. Example: ammonium hydroxide. Now let us do an activity to find out the strength of acid and bases. For that, I am taking here sulfuric acid, acetic acid, sodium hydroxide, and here this is ammonium chloride. First of all, let us prepare the solutions of the sulfuric acid, acetic acid, sodium hydroxide and ammonium chloride. So now here we have prepared sulfuric acid solution and acetic acid solution, sodium hydroxide solution and ammonium chloride solution. Now let us test it at first. Sulfuric acid solution. Here I am passing electricity. For that I have taken here battery and LED bulb. So here this bulb and battery are connected in a series manner. So one end of the battery is connected to the second end of the electrode, which is connected to the LED bulb, and another electrode is connected to the battery second end and LED to the battery. Now here the circuit has completed. Now when I put it electrodes, what would happen? Just observe. So here is what happens when I put this into sulfuric acid solution. Just observe the intensity of the bulb. Here the bulb has glowed. Just observe the intensity of the bulb. So bulb is glowing brightly. Now let us test acetic acid solution. So before that I have to clean again electrodes. I have cleaned electrodes here. Now I am taking acetic acid solution. Here this is acetic acid. Now let us test by keeping this electrodes here. Just observe the electric bulb. So here just observe the intensity of electric bulb. So intensity of the electric bulb is very, the LED bulb is very least. So in sulfuric acid it glown very brightly. In acetic acid it is showing very dull. So brightness is reduced when we have tested this acetic acid. Now again I am cleaning electrodes. Now let us take sodium hydroxide. So here I am taking now in sodium hydroxide solution. I am putting electrodes here. Just observe the intensity of light again. The intensity of the light has bright. Just observe here. The intensity of the light becomes very bright. Here in sulfuric acid, sodium hydroxide. Now again I will clean this electrodes. So for every time we need to clean the electrodes so that we will get correct result. Now here I am taking ammonium chloride. So just observe the intensity of the bulb again here in ammonium chloride. Just observe here. Then what happens? It is very least. The brightness of the light becomes very dull. So while keeping sodium hydroxide it becomes very bright. Now here it is showing very dull. So in this activity, when we pass the electricity through sulfuric acid, the bulb has grown brightly, and while passing through acetic acid, the bulb has grown dull. Means brightness of the bulb have reduced. It is showing that sulfuric acid is a strong acid, acetic acid is a weak acid. An acid which is completely ionized in water, that are said to be strong acid. An acid which is partially ionized, that are said to be weak acid. So acetic acid partially ionized, because of that the bulb has grown dull. And in sulfuric acid is completely ionized. There are plenty of ions produced by sulfuric acid in water. That's why the glowness of the bulb have increased. Similarly, while testing sodium hydroxide and ammonium chloride, in sodium hydroxide it is completely ionized and plenty of OH minus ions available there. Because of that the glowness of the bulb have increased. And in ammonium chloride there are less amount of positive ions will be present there. So this because of that the brightness of the bulb have reduced. So it can be considered as weak base. Sodium hydroxide is the strong base, and ammonium chloride, ammonium hydroxide, these are said to be weak bases. So in this way, by conducting electric conductivity, through these different solutions, we can identify that whether it is a strong acid or a weak acid, strong base or weak base. I hope you have understood about strong acid, strong base and weak acid, weak bases. In next session, we will discuss about pH scale. Thank you. Have a nice day.